According to a simple principle, everything that is replaced should result in a better version. However, in some cases, a few modifications can extend the lifespan of a system for over 70 years without rendering it obsolete. Hard to believe? Especially when it comes to a critical military asset like a strategic bomber. One of the most striking examples of this is the Soviet-designed Tupolev Tu-95. To understand its longevity, we must first explore its origins, then analyze the key factors that have allowed it to remain operational and relevant through decades of military service and numerous conflicts. Soviet leadership discovered a major weakness in their military capabilities during World War II. They lacked a true strategic bomber that could reach targets across continents. This realization sparked an extraordinary engineering experience that created one of history's most enduring aircraft designs. The Tupolev Tu-95 took its first flight in 1952 and remains the only propeller-powered strategic bomber still flying today. This remarkable aircraft has dominated the skies for over 70 years with its impressive capabilities. Its range extends to 15,000 kilometers, and it boasts the world's most powerful turboprop engines that generate 15,000 horsepower each. The legendary bomber's versatility shines through its history, from its Cold War origins to its ground operations in Syria in 2015. Like the B-52 Stratofortress, the Tu-95 still plays an important role in military operations today. How can these old machines still be trusted? Is its technology timeless since its inception? How the Tu-95 came to be? The Tu-95 story began with an unexpected stroke of luck. 4 American B-29 Superfortresses made emergency landings in Soviet territory after bombing missions against Japan in 1944. The United States wanted their aircraft back, but Soviet authorities kept them after recognizing their technological value. Joseph Stalin directly ordered the Tupolev Design Bureau to create an exact copy of the B-29. This massive reverse engineering project involved 900 factories and research institutes that created 105,000 technical drawings. Engineers tackled big challenges, especially converting all measurements from imperial to metric units. The new aircraft, named Tu-4 Bull by NATO, took its first flight on May 19, 1947. The Tu-4 was impressive, but couldn't reach continental United States targets and return. So Tupolev developed the Tu-85, a bigger version of the Tu-4, which emerged in 1949 as the Soviet Union's first intercontinental bomber. Military requirements changed in 1950. The new specs were ambitious: an unrefueled range of 8,000 kilometers and the ability to carry an 11,000 kilograms payload. These demands led to the birth of the legendary Tu-95. Why do you think Soviet engineers used turboprop engines instead of jet engines? Andrei Tupolev's team faced a significant decision about engines for their new strategic bomber. They had 3 options: piston engines, proven but underpowered; jet engines, fast but fuel-hungry; or the emerging turboprop technology. The team's analysis yielded a clear conclusion: the piston engines of the Tu-4 lacked sufficient power to effectively propel such a large aircraft, while the AM-3 jet engines intended for the T-4 bomber consumed excessive fuel, compromising the necessary range. In contrast, turboprop engines struck an ideal balance, delivering greater power than piston engines while offering superior range compared to early turbojets. American B-52 Stratofortress and several British long-range aircraft projects also started with turboprop engines. The Soviets stuck with this setup while Western designers moved toward pure jet power for their strategic bombers. The Soviet government approved Tupolev's turboprop-powered Tu-95 design on July 11, 1951. This choice proved brilliant, giving the aircraft impressive speed and extraordinary range. The first Tu-95 prototype's construction started in 1951 and finished by September 1952. Test pilot Alexei Perelev flew the historic first flight of the Tu-95-1 prototype with its 4 Tu-TV-2F engines on November 12, 1952. Testing went well at first, but tragedy struck on May 11, 1953. During the aircraft's 17th test flight, a catastrophic propeller gearbox failure caused the prototype to crash. Perelev and 2 crew members died. though 9 others parachuted to safety. Early reports pointed to an engine separating from the aircraft due to manufacturing defects. Later analysis showed the reduction gear failed first, highlighting the complex engineering needed for these powerful turboprops. Work continued carefully on a second prototype, the Tu-95-2. This version got more reliable 12,000 horsepower Kuznetsov NK-12 turboprop engines instead of the problematic Tu-TV-2F units. After reassembly at Zhukovsky Airfield and thorough ground testing, pilot Mikhail Nuktikov flew the second prototype on February 16, 1955. The second prototype exceeded expectations by reaching speeds over 900 kilometers per hour faster than many aerodynamicists thought possible for propeller-driven aircraft. These impressive results led to Tu-95's serial production starting in January 1956, even before completing all tests. The Tu-95's intimidating presence masks a wealth of engineering breakthroughs that have kept this Soviet-era bomber relevant for over 6 decades. This aircraft challenged conventional designs of its era. Soviet engineers added several groundbreaking features that challenged aeronautical engineering limits. Engineering marvel: the Tu-95's unique design features. The Tu-95's extraordinary propulsion system stands at its core. 4 Kuznetsov NK-12 turboprop engines that each drive a pair of contra-rotating propellers. No other aircraft matches this 8 propeller configuration's power and efficiency. Each NK-12 military engine delivers an astounding 15,000 shaft horsepower, making it the most powerful turboprop ever built. 2 propellers mounted on the same drive shaft spin in opposite directions in the Tu-95's contra-rotating system. This clever setup brings several key advantages. The system delivers 6 to 16% better efficiency than single propellers, which helps give the bomber its exceptional range. The opposite spinning propellers cancel out rotational airflow effects that could impact control surfaces. This setup turns massive power output into forward thrust better than any single propeller could. This propulsion system helped change the Tu-95 into an exceptional long-range patrol platform and formidable missile carrier. The aircraft stays viable even after 50-plus years since its first flight. Perhaps the Tu-95's NATO bear name comes from its loudness. The Tu-95 ranks among the loudest military aircraft ever built. Submarines can detect it flying overhead. 2 main factors create this thunderous sound signature. The propeller blade tips move faster than sound. Each Tu-95 engine powers contra-rotating 4-bladed propellers. This creates 32 individual blade tips that generate their own sonic booms while spinning. The contra-rotating design adds to this thunderous noise. Tyler Rogaway of the War Zone describes it as a mix of standard jet engine howl with an exotic and unsettling high-frequency roar. Higher frequency noise makes the aircraft easy to spot from far away and can damage crew members' hearing. The Tu-95's most striking visual feature shows in its swept wing design, angled precisely at 35 degrees. This makes it the only mass-produced propeller aircraft with swept wings. The swept wing design let engineers place a large bomb bay with combat loads right at the center of mass. This centered design made the aircraft handle better and deliver weapons more effectively. The fuselage design follows standard principles. Engineers mounted the swept wing in the middle, so the main wing spar crosses through the fuselage ahead of the bomb bay. This setup strengthens the structure while keeping operational flexibility. The Tu-95 Bear bomber's remarkable performance metrics command respect beyond its place in history. These technical specifications show why this Cold War veteran remains the lifeblood of Russia's strategic aviation fleet even after decades of service. Technical specifications. The Tu-95's exceptional endurance defines its character. This aircraft can cover intercontinental distances without refueling, boasting a maximum range of approximately 15,000 kilometers. The prototype demonstrated its capabilities as a true global strike platform by reaching an impressive range of about 15,000 kilometers while carrying a 5,000 kilograms payload. Russian Air Force pilots demonstrated the aircraft's prowess in 1989 by setting 60 world aviation records. They proved its exceptional performance envelope through achievements in flight endurance, altitude with various loads, and non-stop flight time. The Tu-95MS variant pushes these boundaries even further with its in-flight refueling capability. The Tu-95 achieves speeds that match early jet bombers, despite using turboprops. Its maximum speed reaches 925 kilometers per hour, while typically cruising at 710 kilometers per hour. The Tu-95M's achievement of 905 kilometers per hour during testing in September and October 1957 stands as extraordinary for a propeller-driven aircraft. The bomber's altitude performance shines with a service ceiling of 13,716 meters. Early evaluations showed impressive results. The second prototype reached 12,150 meters, and the original prototype climbed to 11,300 meters. These capabilities let Tu-95 crews operate safely above most interceptors at the time of the early Cold War. The Tu-95's design allowed it to carry 9,000 kilograms of bombs at maximum range, with increased payload capacity at shorter distances. The early variants featured 6 radar-controlled, turret-mounted AIM-23 guns for protection. Today's Tu-95MS bombers excel as cruise missile platforms. The standard variant carries Kh-55 cruise missiles on a rotary launcher in its weapons bay. The Tu-95MS-16 adds 4 underwing pylons, which brings the total capacity to 16 Kh-55s or 14 Kh-55SMs. Recent upgrades have given the Tu-95MSM the ability to carry advanced K-8-101-102 cruise missiles. These modernized bombers can launch 8 K-101-102 missiles at once, with their total payload capacity estimated around 20,000 kilograms. The Kh-101 cruise missile adds about 5,000 kilometers to the bomber's strike range, which reshapes the scene by turning this classic aircraft into a powerful standoff weapons platform. The massive frame of the Tupolev Tu-95 houses an operational environment that has asked for unmatched skill and endurance from its crews for almost 7 decades. Modern cockpits feature digital displays and computer assistance, but the Tu-95's interior takes us back to aviation's analog era, where mechanical gauges and physical controls rule. Inside the beast, what it's like to fly the Tu-95 bomber. The Tu-95 gives pilots a set of challenges that has created some of Russian military history's most skilled aviators. Operational records show that the Soviet Air Force picked their best pilots for Tu-95 bomber crews because the missions were so demanding. These talented crew members face big physical challenges. A typical schedule had them flying 10-hour missions twice weekly, which added up to about 10,200 flight hours each year. Even the most experienced aviators found these extended missions testing. The Tu-95's designers didn't put comfort first. Crews say the aircraft isn't pleasant during long missions. The contra-rotating propellers create extraordinary noise. Interceptor pilots can hear the Tu-95 over their own jet engines. This constant noise makes crews tired faster, which led engineers to cut vibration by half in newer versions. On top of that, early Tu-95 models had operational risks that later modifications fixed. The original manual prop feathering system was clumsy and led to a fatal landing accident early in service. This led to an automated feathering system. Cold weather brought another challenge. Oil would freeze in the engines during ground operations until special low-temperature oil blends solved the problem. Notwithstanding that, crews grew fond of the mature Tu-95. The aircraft handled well, showed remarkable sturdiness, and was relatively easy to maintain. These qualities helped give the Tu-95 a lower accident rate than other strategic bombers of its time. The Tu-95's overall safety and reliability have proven solid despite early worries about missing ejection seats and emergency bailout risks. These features help explain why it served in the military for so long. The Tu-95 Bear bomber's threatening silhouette became a symbol of Soviet military power against the West during the Cold War. This aircraft was a vital part of the Union of Soviet Socialist Republics' strategic triad. It projected power globally before intercontinental ballistic missiles took over nuclear strategy. Cold War Guardian. The Tu-95's role in Soviet strategy. The Tu-95's strategic value came from its remarkable range. These bombers could strike U.S. targets from Soviet soil. Their unrefueled combat radius stretched beyond 5,000 miles. This gave Moscow reliable nuclear strike capabilities early in the Cold War. Tu-95's crews managed to keep exceptional readiness through constant training. Their Arctic missions focused on practicing attacks against American targets across the polar region. The crews didn't carry live nuclear weapons during these exercises. Unlike their American counterparts, the Soviet Air Force's best pilots joined these elite air crews. They flew about 200 hours each year. The Tu-95K model carried the powerful Kh-20 nuclear cruise missile. Military analysts called these aircraft long-range missile trucks because they could strike targets from significant distances. This standoff attack capability made American defense planning more complex. Tu-95s patrolled western borders almost non-stop during the Cold War. The first interception happened on December 5, 1961. This started a pattern lasting decades. A single interceptor squadron at Keflavik caught 340 Tu-95s in 1985 and 1986 alone. The encounters weren't real attempts to breach Western airspace. They served as sophisticated intelligence operations that both superpowers ran regularly. The Tu-95 RTE's model became a Cold War icon through its maritime surveillance role. These confrontational patrols stopped briefly after the Soviet Union fell. Russian President Vladimir Putin ordered their dramatic return on August 17, 2007. Tu-95 Bears and Tu-160. Black Jacks flew missions over the Atlantic, Pacific, and North Pole that day. This marked the Bears' new chapter in its long service history. The Tupolev Tu-95 remains the lifeblood of Russia's strategic air capabilities well into the 21st century. Despite its early Cold War-era design, modern warfare demands have pushed this venerable aircraft through extensive modernization to keep it working as an effective platform. Modern warrior, how the Tu-95 remains relevant today. Russia's Ministry of Defense launched a complete Tu-95MS modernization program in December 2009. Tupolev and Beriev aircraft companies oversee this ambitious project to extend these strategic bombers' operational lifetime. The modernization applies to aircraft built after 1986, which includes about 30 to 35 planes. The program unfolds in two distinct phases. The first phase makes bombers compatible with newer weapon systems and replaces critical navigation equipment. The second phase changes the aircraft into the Tu-95 MSM variant. This upgraded version features the Novella NV1021 passive electronically scanned array radar and S021 navigation system. The updated NK-12 MPM turboprop engines paired with new AV60T propellers mark a big improvement. These changes cut vibration levels in half. The first Tu-95 MSM took to the skies for its maiden flight on August 22, 2020. The modernized Tu-95 now packs impressive offensive capabilities. The Tu-95 MSM can carry 8 Kh-101-102 cruise missiles instead of 4, doubling its strike potential. Engineers reinforce the wings to handle these bigger and heavier missiles. The weapon system uses both internal and external mounting points. The original internal rotary launcher holds 6 Kop-55-5555 missiles, while 4 new double missile pylons under the wings carry 8 more Ka-101-102 cruise missiles. These advanced missiles give the bomber an extra 5,000 kilometers of strike range. The Tu-95's first taste of combat came during Russia's military intervention in Syria on November 17, 2015. A year later, Tu-95 MS bombers showed their capabilities by launching Kh-101 cruise missiles at militant positions. Sukhoi Su-35 flanker fighter jets protected these bombers during their missions. A Tu-95 MSM variant, along with an older Tu-95 MAS, marked its combat debut by striking terrorist strongholds in Syria with Kh-101 cruise missiles. These strategic bombers now play a crucial role in the 2022 Ukrainian conflict. Reports indicate they launch cruise missiles at Ukrainian targets from Russian airspace. Russian Aerospace Force currently flies about 47 Tu-95 bombers in various configurations. The ongoing upgrades should keep these aircraft flying until at least 2040. The Tupolev Tu-95 has earned its reputation not just as a strategic bomber, but as a watchful guardian of the seas. The aircraft has maintained a constant presence over the world's oceans throughout its service life. It conducts surveillance missions and shows Russia's ability to project power globally. Ocean Patroller, the Tu-95's maritime operations. The Tupolev Tu-95 has earned its reputation not just as a strategic bomber, but as a watchful guardian of the seas. The aircraft has maintained a constant presence over the world's oceans throughout its service life. It conducts surveillance missions and shows Russia's ability to project power globally. The Tu-95 RTE's variant became a veritable icon of the Cold War with its specialized maritime surveillance capabilities. This version stood out with its distinctive equipment. A large bulge under the fuselage housed a radar antenna that could search and detect surface ships. Two Tu-95MS strategic bombers completed an 8-hour mission over the neutral waters of the Sea of Okhotsk and Japan Sea. These endurance flights showcase the aircraft's maritime patrol abilities as it operates in international airspace over key waterways recently. Russian bombers regularly patrol these most important areas: the Arctic region, North Atlantic, Pacific Ocean, and Black and Baltic Seas. Russian and Chinese bombers flew together on joint air patrols over the Chukchi and Bering Seas for more than 5 hours in January 2024. This groundbreaking coordination marked the first time strategic bombers from both nations simultaneously entered the Alaska Air Defense Identification Zone. The Tu-95's history includes numerous close encounters with Western naval forces. Two nuclear-capable Tu-95MS bombers approached the USS Ronald Reagan in the Sea of Japan in one notable case. Fa-18. Hornet fighter jets intercepted them. The interaction stayed safe and professional, even though the bombers came within 128 kilometers of the carrier. Another real-life encounter saw an aircraft carrier detect approaching Tu-95 Bear bombers through radio signals. The carrier's F-4 alert aircraft intercepted the bombers 250 miles from the battle group. These cat-and-mouse encounters have remained common since the Cold War. The Tu-95 faces unique challenges over open oceans. The aircraft's extraordinary noise signature can work against its maritime surveillance mission. Submarines can detect the bomber flying overhead. The Tu-142 Maritime variant excels at finding and tracking enemy submarines. It can follow them for hours. These aircraft carry sonobuoys to locate submarines and come equipped with torpedoes and mines for potential attacks. The Tu-95MS bomber usually flies no more than 200 hours each year due to technical limitations. The Bear continues to serve as an effective platform that shows Russian presence in international waters despite these constraints. Do you think the B-52 could be developed and converted into a passenger aircraft? The most interesting development of the Tu-95 is its conversion into the Tu-114 passenger aircraft. Tupolev found an ingenious way to turn a strategic bomber into an intercontinental passenger aircraft. The Tu-114's new pressurized fuselage could hold up to 224 passengers. Engineers moved the 35-degree swept wing from its high position on the Tu-95 to a low-wing setup on the airliner. 4. Kuznetsov Mk-12 MV turboprop engines with contra-rotating propellers powered the aircraft, each generating 14,795 horsepower. This massive aircraft stretched 168 feet across its wings and 178 feet in length, weighing 385,809 pounds at takeoff. It performed impressively with a top speed of 541 miles per hour, cruise speed of 478 miles per hour, and could fly up to 5,044 miles. The Tu-114 stole the show at the 1958 Brussels World Exhibition as the world's largest airliner. Though not as fast as the Boeing 707 and Douglas DC-8 jetliners, it carried bigger loads over longer distances. The aircraft still holds several world records for turboprop-powered aircraft. including the Fédération Aéronautique Internationale speed record for propeller aircraft in a closed circuit since 1960. Aeroflot started flying the Tu-114 commercially in April 1961, and 32 planes ended up being built. The Soviet airline used it as its flagship until 1971, before retiring it from domestic routes in 1976. The plane left behind an impressive safety record. Thank you for watching the video. If you find this video interesting, please give us a like and leave a comment before you watch another video. If you feel something is wrong, please leave it in the comment section so that the channel team can improve. We look forward to seeing you in the next videos.